Okay, part two, LeetCode. Um, so this out of curiosity, did any of you guys attempt this week's problem? You did? Did you crack it? Oh, okay, cool. Well, that's actually good because I want to do something a little different this week. I deliberately I feel like we were going like super deep into the algorithm side of things and um kind of getting away from like the technical interview prep side of it, which is fine. You sort of need that too. But I wanted to just kind of go back to basics. So this is a LeetCode easy. There's really no underlying sort of technical things for this. I wanted to do it this week because I wanted to work on the mechanics of it a little bit more. In fact, as part of that, I actually want to give you guys time in lecture to actually try to work the problem in real time. So um, yeah, so this is more of just like polishing your actual sort of LeetCode test taking skills. Um, so we'll queue up the problem. We'll talk about it a little bit, and then I'm going to pause the recording and give you guys some time to actually sort of work on it. And then we'll sort of, and then of course in the end we'll come back and solve it. But does that sound good, guys? All right. So this week we chose longest common prefix. All right, so this problem, write a function to find the longest common prefix string among an array of strings. So it's not a pair of strings, it's an array of strings, which means we could have multiple strings, right? So if there is no common prefix, just return an empty string. So for instance, if, right, so the input's going to be an array or really just a list from Python perspective of strings. So here you can sort of see string here is we have flower, flow, and flight, and the output is FL. Now, a couple things to note that make our life make things easy for us. Note it's prefix, so it's not what's the word for it? It's not suffix. Suffix.
Because prefix is we're looking left to right.
Yeah. Well, exactly. So it's not so it's prefix. It's not suffix, but it's also I'm trying to say like sub
Oh,
thing, substring.
yeah.
It's not longest substring, right? That's a much more challenging thing. Prefix says start at index position 0 and see thing that goes out longest. So that's already something we want to flag. Just looking at the problem scope, right? We know that's so that's going to scope our approach. It's going to dictate how we're going to approach the matching on it. Okay, the second one thing, dog, race car, right? The output's there because there's no common prefix among the input strings. Sure. And let's look at our constraints here. So the length of the overall list of strings is going to be between 1 and 200. So it does seem like, so this is interesting. We probably will never have to deal with a null thing there. And then for the words itself, though, so there's always going to be at least one thing. There's not going to be empty, but the words itself, each word is between 0 and 200 characters. So you can have empty words. This is another big one for us. This is not a huge one, but it does help us. Each word consists only of lowercase English letters if it is non-empty. So not a huge thing to fix. Like we could just do a lower thing or an upper, right? There's ways of standardizing. But remember, string matching, right, is case sensitive in Python. So uppercase T, lowercase t, completely different. If we didn't have this constraint, we would have to explicitly convert to lower to upper, right? There'd have to be some standardizing step for our strings. We can avoid that. Okay, so that's the problem. What are you guys' thoughts? How are you thinking you might want to tackle this?
First, what I would do, I know it's not like the most efficient, but do a for loop that goes through all of the elements to find the shortest length, so that I know when I go and start searching for my prefix that I know exactly the minimal characters I have to search, because I don't want to accidentally search for more characters than I have to, because I know some arrays might have strings that are different lengths. So I'm
Good.
only try it.
So that's a really good catch, and I want to flag that. So So what you flagged is the idea that I already know that there's an upper bound on what the longest prefix is going to be, and that's the length of the shortest word in that list. Right? I mean, it's intuitive, but that's an important idea because that also potentially scopes things. So we know, like you said, we don't we know that is the maximum possible prefix length. I don't need to look beyond that. In fact, maybe that's actually a good comparison point, right? If I can grab the shortest word, that's probably something I might want to use. Okay, so that's good. Yes. All right. Any other thoughts? So we want to sort of find that one. I think that's a really good kind of starting place for us. Any other thoughts? So how do you think you might actually approach figuring out the prefix? What might the logic for that be?
We have to set a string variable called prefix as an empty string,
Mhm.
and then when I find the, the length of the shortest word,
Mhm.
I'm go through, I'm gonna do a for loop where the length is the shortest word,
Mhm.
and then I'll check to see if all of the, if all of the words in the specific index have the same character, I'm gonna
Mm.
add it to my prefix string. But as soon as one is different, I'm gonna break it and return whatever I have on the prefix.
Mm. Okay, perfect. I ended up doing something a little different, and we're going to talk about this because this is no, it's good. The instinct is good. I think that approach will work. But basically, you're going to loop. You're going to look for matches
Mhm.
at a very high level, and there's different ways to structure this. Whether you want to do a for loop and a break, or you want to do a while loop. That while it's a match, and then obviously end well done. Right? You could both ways work. There's not a wrong way to do that. And then return on that. Um, and one thing I would say is with this, you may want to, and the thing I want to practice with today, and this is the other thing in terms of building this out, is each step working on your print statements, working on your validations, working on doing it. So, like for me, one of the things I did was I matched on two words first. Built, figure out how to build out common prefix for two words, and then theoretically figure out the mechanism to extend that logic further. So, because again, building it out piecemeal, right? That's why I want to sort of focus on the mechanics. Because I think one of the problems with, I think the way I've been sort of showcasing some of the previous problems is like we talk through it and then I'd code it start to finish and be like, here's the solution. Oh, right. But that's not how this works. That's never how that works. It's always messy. It's always iterative. It's always like, let me inch towards a solution. Let me build this out and sort of scramble together. And so one of the things I want you guys to practice, particularly with these things, is building out these sort of the sub elements of your solution and then making sure you're printing them out, making sure you're visualizing them, making sure you're seeing them as you're doing it. And so that's really what I want to practice with you guys tonight. And the other thing again is verbalizing if this is an in-person interview or commenting if this is an online interview. Documenting. Process is as important as result, if not in many ways more important. Um, Particularly in an era where you can copy and paste code, right? It's not, they want to see you work through the problem. And so going through the what's the word? But going through the motions of working through this, documenting your assumptions, documenting your approach, experimenting, testing, right? Working through it. That's what they want to see. And again, like particularly if you're doing sort of like a remote hacker rank type thing, um, where they're recording and seeing that, like that's what they're looking at. So they can't see what's going on in your head. So you need to be able to communicate that even while you're solving the problem. Okay. So with that said, like I said, I want to pause the recording now. I want to give you guys a chance to sort of, again, work through that yourself, give you some practice doing that, and then we'll come back and we'll solve that together ourselves. So, any questions before we do that?
In the definition, what does it mean, the arrow there? Like you have self strings and then there's a colon and it says list string and then there's an arrow to string in the function definition in the code
This,
section.
this thing right here?
Yeah.
Yeah, so good question. So this is a notation it's not sort of classical Python, but it's something that we sort of see increasingly as a an input. So the first thing is you'll notice everything's wrapped in classes. And that always makes the notation a little bit more complicated, but it's fine, we can work with that. So it's a class, and then you have a sort of method within that, and that's why we have sort of the self input. But this is a thing where you take in a parameter. And in this case, right, it's going to be strs, short for strings. But you'll notice here, it actually defines the input parameter type. And again, Python doesn't require that. Some languages do. Python doesn't classically do that, but it's sort of an opt-in thing because what people have realized is that it does kind of help it because it defines sort of the functional thing. It says we're going to take in a list of strings, and the arrow notation says it's output. And this definition is going to output a string. So again, not classic Python, but that's something that I think the Python community has just kind of embraced as a sort of a coding thing because it does help to standardize your expectations for it and helps to sort of deal with input, type errors with input type things. That says this function is going to take in a list of strings, it's going to output a string. So that's what that notation is telling you.
Okay, got it.
Well, yeah, I mean, if you're right, that's not something that like we've worked with classically, but if you're coming from other programming languages, you'd be like, oh yeah, of course. But yeah, so we've sort of belatedly embraced that design motif too, I think. All right, any other questions? All right, I'm going to pause the recording. Okay. One minor thing I wanted to mention, only because we just talked about this, was when you do go hardcore technical interviewing, do lock in on a language. Yeah, just again, I mean, it makes sense, but we were talking about this before. When you're code switching, when you're jumping through, is you want, granted, like inevitably you're going to make syntax mistakes. You're going to sort of do that, but you want to, you don't want to be sort of code switching from one language to the other. Just try to lock in. If whatever language you feel most comfortable in, just that's your language, and just do that and try as much as possible. I know it's not always, but like just lock in on that. Okay, so that's the first thing I'm gonna say. The other thing I'm gonna say with this, which was interesting to me, this is another reason why I liked this problem, but it wasn't sort of a deliberate thing, was I ended up overthinking the solution. And what I mean by that is I ended up having to do less than I thought I would. And let me be precise on this. So my steps for this were kind of similar to yours. Get minimum. We're going to talk a little bit more about that, but like, get those. And then I was like, okay, let me get the longest prefix between two of them. And then I was going to encode some logic to say, once I had the longest prefix between two of them, test it to see whether or not that works, and then maybe like there would be a fixing mechanism, or maybe something like you were proposing where you have to like compare all of them concurrently, things like that. I'd have to sort of think about something, but I never had to get that far. This is the crazy thing about this one, which is, and it's not here, but it ended up being that like what I did shouldn't have worked, but it did work. I know that sounds odd to say, but like it solved all the problems. So I didn't, in other words, the mechanism I chose, I don't know if it was because of the mechanism I chose, but like somehow it worked, even though it shouldn't have, is what I wanted to say. And it goes to the point of saying like, sometimes, don't get in your head about it. It's like, test it, work it, solve the simplest problem. And then suddenly you realize, oh, like, okay, I don't need to do maybe what maybe what I thought I did. Okay, so first thing, so this was something you already sort of did before. And again, rather than just typing out the ultimate solution to the code, we're gonna do a little bit more iteratively. Am I sharing screen with this? Can you guys see this, by the way? Is this like legible at all?
No, but
Okay. Oh yeah, you guys have it on the Zoom, but still, let me just, yeah.
Oh, it's a lot better.
That's better.
Yeah.
Kind of. I'll make it bigger too. And I'll make this because I don't really need that. I'll make this there. Okay. Folks on the screen share, you probably don't need this much, but whatever. Okay. So for this, I'm just going to, so the first thing we already called out was, okay, I want to get the minimum, right? Because again, basic logic thing, if I'm going to be comparing two words, it makes sense that at least one of those words should be the minimum. So one thing you may or may not know about this, but there is a min function that can return the minimum value of it. It's not a list. It's interesting. It's not, and I had to look this up. It's not a list attribute. So you won't do like strs min. Like you're gonna do that, but you have a function. So I'm just gonna say return min strs. All right, so let me just kind of run this. Let's see whether or not, yeah, I know it's the wrong answer, but the important thing is, does it return? Okay. All right. So let's see. Output is expected. My output is flight, really? It's flight.
Min is the lowest value of the string, which is the last value.
Mine shouldn't be returning that. It should be returning the minimum thing of it, right?
What do you mean, like, length?
Yeah.
Wouldn't you have to enclose it in the length?
Oh, do I need to do minimum length?
Yeah, so it'll be, you put length and then the
Oh,
Like you need to like add a key.
Key
after
equals len.
Yeah. Yeah, it's like second parting.
so minimum, so. Because I know this worked for me, which is why I'm a little surprised. So I'm not adding, sorry, what's the lexicon you do? What's the?
Is it min stirs key equals len?
Yeah. Stirs, comma, key equals len.
Stirs, comma.
Like inside.
In parentheses.
Oh, I see. So within min, I do str.
Stirs, key-
Oh, I see. Okay.
No, just len. I think it's just.
Okay, well, this is why we test it. Low, yep, that's right. Okay, cool. All right, so that got me my one thing. So, okay, so now I know, and that's interesting that I did that because, okay. So now I have the first thing. So now the next question is, okay, well, what is the other word that I compare it to? And there were different ways in which I could sort of think about this, but one of the challenging things with this is because you have a variable length of things. So you could have a scenario in which you have no words. You could have a scenario when you have multiple words, things like that. And so I couldn't just arbitrarily choose, like I couldn't say take minimum and take index position 0 or take it, right? Because I couldn't, because what if index position was the minimum or if there wasn't anything there and then you're going to get these key errors. So I had to get something that was a little bit different, but would still return something irrespective of size. And so I played around with that for a while. And then what I realized was, another sort of just using this, I could also pull max and run that one. Let's see here, flowers, that returns flower. Let me just check case 2, race car. So I could grab my two words just by referencing min and max. And the second word really didn't matter, right? As long as it was greater than or equal to min, which it would be, it wouldn't matter. But the point is, this was a way of grabbing potentially two discrete words, or the same word if it's null or one word, but it was a way of potentially grabbing multiple words in sort of a flexible way. It was like, okay. So now let me format this a little more, just make sure I'm doing this properly. So let me just say A, comma, B equal, let me say min, strs, key blank, and max. S key. And then I'm going to return. Say, okay. The min is all right, so let me min word is flow and the max word is flower. Cool. And then min word is dog, max is race car. Cool. Okay. So now I've got my two words. Haven't done anything meaningful with them, but I've done them. So now the question is, okay, so how do I find sort of the substring? And again, one of the things we said is that we're going to loop, and you could theoretically do either way. You could do a for loop with a break, or you could do a while loop. And I ended up just sort of doing a while loop. Doesn't not right or wrong, but I said, okay, so what I'm going to essentially do is I'm going to structure this loop as follows. I'm going to say, okay, so while the index is less than length of A, and index of both words is the same, increment index. And then, and so the idea is, right, so that's going to be sort of match. So I'm going to say, okay, if this matches, go ahead. If this matches, go ahead. If this matches, go ahead. And then once that breaks, which is one of two things is going to happen, right? Either I run out of the word, right? Either shortest word ends or no longer matches, right? Those are sort of my two possibilities. Then I'm just going to return word up to that index. Okay. And I got to play around with it. I'm like, is it, and then I was like, well, is it exactly the index? Is it index plus one? I was like, am I calculating that right? I'm going to need to play around with that, but right, that's what we test for. Okay. So I'm going to say, I'm going to start with index equals 0. And then I'm going to say, so while I is less than length of A, and AI is equivalent to BI. So while that's true, oh, gotta bracket it, then I plus equals 1, right? So I just keep incrementing. And so I keep my loop going. Then once my loop is killed, so I don't return anything within the loop, but once my loop is killed, then my return, I'm going to change this thing. I'm going to get rid of that. I'm now instead going to return A. Starting with, I could just say 0, or I could just say run it all the way. B, run up until that index point. Anyway, had to test that. I wasn't sure intuitively if that was right or if it was going to be A plus 1 or not, but let me just kind of test that, see if that works.
AI. Index of I.
Oh, thank you. Yep, that would. Okay, so let's see here. So my output is flow. Interesting. And so I got the second one right, which is null. Okay, so I got the null one right. This one's failing though. Why is it failing though? Let me see. So it's outputting the entire. And well, I is less than, so that shouldn't have looped there. So why is my logic there? Right. Oh. Sorry, let me make this a little sorry, guys. Seconds, probably. Okay. So my current output is looping OW.
Oh, it's almost for this flower.
Yeah.
Because
You're only
the letters-
Oh, it's going flow and flower, so it's not, yeah, so it's not matching it. Okay. So in fact, so this is failing on my thing.
It's technically correct, but it's not taking
Yeah, it
the
didn't
third
count
word
like-
into account.
Correct. It's not, so I'm actually failing on my other word. So why did this, so this is funny because this is the thing that I thought actually was going to throw me off, but I wonder if there's a weird syntax thing that I did wrong because let me check something. See, I did not do key equals length. I just did min and max directly. And when I ran this, let me just run this again. I'm kind of curious about.
If you do min and max directly, then you're not gonna get this, you're gonna get the first and the last, not the shortest and longest.
Interesting. Let me test that. Well, so here's the funny thing. So I passed this, assuming this, and this was the interesting thing. Here, let me actually just submit this.
But it's because for whatever reason, the data sets that they're using to test against you is just.
Exactly.
You would still realistically would have to compare all the screens.
Exactly.
Yeah.
So let me, so sorry, let me, I am curious about it. So that's the funny thing. So it worked, right? I got 100%, and that was the point where I'm like, oh my God, like, I guess I'm done, right? Because then because to your point, like I was thinking on that too. So I'm just kind of curious now. So I'm going to see here. So print, I am curious what print A. So it returns flight and flower. So min is, so when I run min, it returns flight. Max returns flower. Interesting. And case B, car and race car. What is it basing this on?
Oh,
Is it based on-
alphabetical string that the
Yeah,
ASCII value of
Yeah.
the ASCII.
Oh, it's doing
specifies
ASCII.
the first character.
Oh, intriguing. Fascinating. So why does that work for me though?
Hey, if that was your interview.
I love how I like fascinating.
It would eventually fail, but the data
Yeah.
set that they use just happens to work for
Yeah,
you.
once in your bid.
Well, and that's the point I wanted to get at with this was that like I thought as a next step, like once I got this working, I'd then have to be like, okay, now I have to, yeah, because and that was ironically what ended up happening in that first thing because it was matching flow and flower were matching FLOW, but it was failing because it should have been FL. So, but for whatever reason, the particular set of words I worked ran for all 126 use cases. So, but it's an interesting thing, right? I'll be fully transparent. Like this is not an optimal solution, right? This is clearly, but it worked.
So you did it.
So. Found the shortest word, I removed that one from the list.
Mhm.
Then I use a while loop to I use the string method starts with
Mm-hmm.
to see if each of the words in the list starts with that one.
Hmm.
I count how many start with it. If that number,
Start with the entire word
with
or
the entire word.
okay.
If that number equals the length of the list, then that means I found the longest prefix. So I break out of the loop and then I return that. If it doesn't, then I
You
take a letter
decrement.
away.
You keep decrementing
Yeah.
until either you return. Okay. Oh, nice.
Starts with is this built-in string function?
Yeah.
Oh, okay.
Hmm.
I would start with the the index of the first, and I would compare every word. If that
Mm.
matches, then I would go to the next one. If that matches, it would keep going. I
Yeah.
kept failing when it got to two strings that were two strings of blank.
Oh, interesting.
Yeah.
Yeah. Huh. But yeah, to your point, even without the starts with, if you just start with, does shortest word equal every word to index position of shortest word,
Yeah.
that's length of shortest word. Oh, it did the hands up thing again. Oh, no. And you could decrement, it's the same idea. You don't even need the starts with thing, but yeah, basically just kind of do that in decrement. So, but yeah, that's probably the best way to honestly code that out. So, but oh, now I have lower hand. Thank God. Okay. So yeah, okay. So again, points here. To me, this is a fun problem. You know, nothing, no crazy Kruskal's algorithm, dynamic programming business. Again, start working the program, test your outputs, as you can see here, right? Doesn't necessarily work the way you think. Iterate, increment, and just vocalize as you're going through it. And sometimes you get lucky and inadvertently stumble on a solution that works better than you thought it would.
So
So,
the ideal solution would be going from working further from the min max based on length. And then trying to then do
I
the breakdown.
I mean, so I think my plan had been once I found that string, my plan had been to then loop that string, and if it failed, have some kind of like decrementing fallback on it. And then, but I didn't have like a really elegant approach. I think because I had focused on like just getting the logic of how you match and making sure I was matching. And then like I tested and I got that. And then I tested, I was like, wait a second, why is this passing everything? And I kind of stopped it there. But yeah, I would have had to think through the logic once I had that of like, okay, how do I structure this into a string? Like I hadn't even gotten that far or how do I structure this into a loop to compare all words? But I think your approach of, starting at max and decrement was probably the way to go. But all right, I'm going to stop the recording there.